Hello friends, today this is GATE 2019 set 1. This is the problem on pile foundation. So we are continuing with pile foundation, and you can see the importance of pile foundation. Every year you will be having problems on pile foundation. So the details are given. RC circular pile, length is given, diameter is given, embedded in a stiff clay. The properties of the clay is given, and when it is a stiff clay, Cu value is quite higher. Therefore, the value of alpha will be on the lower side. Softer the clay, alpha will be on the higher side. So adhesion factor is higher if it is soft clay. The reason being that when you install the pile into a softer clay, the clay is going to stick around the pile. But if it is a stiffer clay and the pile is inserted into the ground, there is going to be little gap between the clay and the pile, and therefore alpha will be on the lower side. As you can see, this is a stiff clay. So in a stiff clay, the value of alpha has to be on the lower side. And you need to calculate net ultimate pull-out load of the pile in kilonewton. So you have a pile embedded into a stiff clay, and you need to calculate the pull-out load, net pull-out load. So net pull-out load, Q net pull-out, will be the moment you are going to pull this pile up, there will be a frictional force acting on the pile like this. So you need to calculate this frictional force which is going to act on this pile. So the capacity, net capacity, pull-out capacity will depend upon this frictional component. So what is this frictional component? Unit skin friction, that you should be able to calculate. So it will be simply equal to the magnitude of the unit skin friction, and it is going to act over the shaft of the pile. So you multiply it by the shaft area, and because it is net, the weight you are not going to consider. The weight of the pile will not be considered in net. If it is total, then consider this. So as you know that in a stiff clay, Fs will be alpha times Cu, and this will be, it is a circular pile, so perimeter will be pi d and multiplied by length. That becomes the shaft area. So the simple calculation is 0.5 into 110 into pi. The diameter is given to us and length is also known to us. So much of kilonewton. So this becomes 55, this into 7.2 times pi. So if you calculate it, this is the answer. So net pull-out capacity of this pile is so much of kilonewton or 124.4 tons. So good capacity. Now, next problem is gate 2018. So we will see that. So 2018 problem. Let us see that. So you have this 2018 set 2. And the problem is like this: a group of 9 piles arranged in a square pattern, 3 by 3 square pattern, is embedded in dense sand underlying recently filled up clay soil. So you have a filled up clay layer, and the perimeter of a pile, so single pile, is given as 126 centimeter. The size of the pile group is 240 centimeter by 240 centimeter. This is also given in the problem. The recently filled up clay, properties are given. The value of Cu is 15 kilopascal. It's very soft. Less than 25 kilopascal is going to be very soft. So it is very soft. Its consistency, and the total unit weight is given as 16 kilonewton per cubic meter. Calculate the negative skin friction. Negative friction or negative skin friction load acting on the pile group. So you will have to calculate the negative skin friction that's going to act. So it's a simple problem. You have got the piles 3 by 3. This is the pile. plan view, 3 by 3 piles, and this pile is embedded into dense sand. The layer of recently filled up clay soil, so filled up clay, and this dense sand, right? The perimeter of one pile, so perimeter of one pile or single pile, P of single pile will be equal to pi d, equal to 1.26 meter given, and the size of the pile group is 240 by 240 centimeter, the size of the pile group, and the filled up soil has got Cu, which is given to you here, 15, and gamma is also given as 60. So if it is so soft, naturally you can refer as 2911, where alpha value will be 1. For very, very soft soil, the value of adhesion factor will be 1. So if you want to find out the negative skin friction, the negative skin friction is going to develop because this filled up soil will try to settle down. It gets decomposed over a period of time and it will settle. So its position after settlement will be somewhere here. Naturally, when it is going to settle, it will induce a negative friction in the downward direction. So the drag force is going to act in the downward direction because the filled up ground is going to settle. So you need to calculate the number of piles are known to you. So therefore, this we can calculate. The negative friction load Q, negative friction load in kilonewton will depend upon what is the number of piles multiplied by the negative friction developed on single pile, right? So number of piles you already know, it is 9 piles, and a single pile, this negative force on a single pile will depend upon what is the unit skin friction. It is alpha times Cu into the perimeter. If it is going to act over the pile, what is the perimeter? So perimeter of a single pile multiplied by ln, the length of negative skin friction zone. Now, this negative skin friction zone is given in the problem as 2 meter. So this ln is given. So here ln equal to 2 meter. So if you know it, this is known to you, this is known to you, this is known to you, this is known to you. Therefore, 9 into 1 into 15 into 1.26 multiplied by 2, you calculate this and you get the answer in kilonewton. This is based on that premise that this is each pi, when it is settling, it is inducing a frictional force. Now, when it is acting as a group, so the negative skin friction based on the uh, group concept only on the periphery, because these parts, the soil within will uh, will be settling down, and in group capacity the friction is going to come only on the periphery. So the frictional force will act on the periphery. So on block shear concept, if you calculate it, it will be perimeter of the group multiplied by length multiplied by the negative skin friction. It is acting in the downward direction. So perimeter into length, this, plus the weight is also going to move in the downward direction. So the total downward force is going to be weight of the soil within the group. So on group concept, there is another expression. So based on group concept, the negative skin friction, the perimeter of the group, you can find it out, 2.4 meter by 2.4 meter, 4 times, it is a square pattern multiplied by 2.4. This becomes the perimeter of the group, and the length is known to us, 2 meter, ln it should be. So the downward force will be acting over this multiplied by, this will be alpha times Cu, that is 15, plus the weight of the soil. You can calculate it, the weight of the soil, which is confined between, it is a square pattern. So 2.4 by 2.4, it will be 2.4 square, isn't it? And that becomes the area multiplied by the length. So length is going to be 2 meter. This becomes the volume multiplied by the unit weight. Now the unit weight is given to you as 16. This becomes the weight. So if you calculate this, you will be getting the answer in kilonewton. This will be 2. Out of these two, whichever is greater should be taken as the total negative friction load. So total negative friction load will be greater of 1 and 2. So we need to calculate it, simple calculation. So if we calculate, let us calculate this. So this is going to be 340.2 kilonewton, one answer. And on group concept, let us calculate this. 4 into, 472.32. So there is another answer. This is based on group capacity and this is based on individual pi. So the total downward force we have calculated, the drag force due to this negative skin friction which is acting in the downward direction, and weight. So our greater of 1 and 2 is 472.32 kilometer. This is the answer. So the negative friction load is going to be 472.32 kilometer. Right? This is how we can calculate, and this is quite simple, nothing complicated. This was 2018 set 2, and in 2018 set 1, another problem on pile foundation that we will attempt now. We'll try to do all the problems of pile foundation so that various problems along with the problem we can have the related theories, and you will learn the theory as well as how to solve the problems. So those things I will be discussing about. So now this is set 1. The problem of set 1 is 0.5 meter by 0.5 meter square concrete pile is to be driven in a homogeneous homogeneous clay soil. In a clay soil where the undrained cohesion is the soil properties is 50 kilopascal and its unit weight is given as 18 kilonewton per cubic meter. The design capacity of this pile, the design capacity of the pile is 500 kilonewton, and alpha is mentioned in the problem at 0.75. So that is the value of alpha. That's a given. The length of the pile required for the above design load, the length of the pile for the above design load will be so much of meter. So say this is also a simple problem. The pile is going to be square in cross section. So this is a pile. The cross section is going to be a square 1.5 by 0.5 meter. and this pile is embedded into the ground, right? And the value of Cu is known, 50, alpha is known, gamma is known, and the design capacity that is the allowable or the safe load carrying capacity or the allowable load carrying capacity is given to us 500 kilonewton. And for the above design load, for here in the problem, it is given for factor of safety equal to 2. Therefore, for F equal to 2, factor of safety equal to 2, the ultimate load carrying capacity of this square pi will be allowable load carrying capacity or design load capacity into factor of safety. So it becomes 1000 kilonewton. So having got this, now you need to find out the length. So we know the formula, Q ultimate equal to Fs into shaft area, unit end bearing into area of the pile at its end. So calculate Fs will be alpha times Cu. So this will be kilopascal. Calculate this. Then calculate the shaft area. Now the shaft area of this pile will be the perimeter of the pile into length. The perimeter will be 4 times the dimension, that is the perimeter, into length, and the length of the pile is to be found out. So let the length of the pile be L. So you multiply it by L. This becomes equal to 2L. Then calculate QE, which is CNC, where NC is 9. So 9 times Cu. So this becomes 9 into 50. So 450 kilopascal. This is now area of the pile at the tip will be B square. So this is going to be 0.5 square. That is 0.25 square meter. So if you substitute all the values, you can get the value of, so substitute in equation 1 and you will be getting all the values. 0.75 multiplied by 50 will give you 37.5 kilopascal. So this is going to be 37.5. So on substitution, what you get? Qu equal to 37.5 multiplied by 2L plus 450 multiplied by 0.25. Now the Qu is 1000, so this becomes 1000 equal to this. So let us simplify this. So 1000 minus this term, that is 450 into 0.25, 887.5, and you want to find out L, therefore divide it by 37.5 into 2 will be 75. So divide it by 75, you get 11.83. So by simplification, therefore, we get the length of the pile equal to 11.833 meter. So this becomes the answer. So we can attempt this problem quite easily. There is no difficulty in solving the problems. So the gate problems are like this, and I will take one more problem, that is 2017. So we will be going to the next problem, and that is also quite interesting. So you are seeing that the problems are going to be quite interesting. 2017, set 2. Set 2. The problem is two identical concrete piles. Two identical concrete piles having the plan dimension, of 50 centimeter by 50 centimeter. So it is a square pile. This is also 0.5 meter. This is also 0.5. So the plan dimensions of the pile are given, are driven into a sandy layer, are driven into a sandy layer, and the properties of sand is given to you. Phi 30 degree, NQ value is 24, bearing capacity factor is given to you, and the ground conditions are shown. Conditions are shown in figure below. Figures. So you have a pile like this. There is one pile driven into dry sand. The sand is dry. The length of the pile L equal to 20 meter, and that's given. And the properties of the dry sand is phi 30 degree and gamma equal to 18 kilonewton per cubic meter, NQ equal to 24, and this is the point load QP1. So another pile identical is like this. So identical, but here the sand is submerged. So this was dry and this is submerged. Phi no change, 30 degree, and gamma saturated now is 19 kilonewton per cubic meter, NQ equal to 24. So two identical piles, 1 and 2, and therefore here the point bearing capacity is or the end bearing capacity and resistance is given to you as QP2. So here, which is the correct statement it is being asked? Which is the correct statement? A, QP1, the point bearing resistance of pile 1 is greater than QP2 by about or approximately 100%. Then B is QP1 is less than QP2 by about 100%. And the C is QP1 is greater than QP2 by about 5%. And the D is QP1 is less than QP2 by about 5%. These are the four statements. Which is the correct one? So by calculating, here it is dry sand, here it is submerged. Naturally, what is the submerged unit weight? Gamma prime. So the submerged unit weight will be 19 minus approximately the unit weight of water, you can take it as 10 kilonewton per cubic meter. So it becomes 9 kilonewton per cubic meter. So from 19 it becomes 9. And therefore, if you calculate this QP1 will depend upon the value of what is the surcharge. So Q and Q. So Q and Q, right? And multiplied by the area of the pile shaft, where Q is called surcharge at the pile's tip. So what is the surcharge Q at the pile's tip here? Here, this is the surcharge. Here, this is the surcharge. This Q will be here, it will be because submerged condition, gamma prime into length of the pile. Length of the pile here also it is 20 because it is identical. So diameter and length are equal. Ground is also same, only thing it is dry and then during rainy season it got submerged. So gamma prime here is just 9, whereas gamma is here 18. So the value of QP1 is the direct function of Q. NQ is same, 24, no change. Cross-sectional area at the end is same for both identical piles. So it's a function of Q. So in QP1, the Q is going to be 18 times, that is the gamma T is 18 kilonewton per cubic meter multiplied by the length of the pile, so much into area, right, into NQ. So if you calculate this Q value, the Q is going to be 18 into 20 multiplied by NQ multiplied by A. NQ and NA, for both it is going to be same. So here it is QP2. Now, in QP2, in the second condition, because it is submerged, you see gamma prime is going to be 9. So here it will be gamma prime into L. So 9 times 20 into NQ into A. So QP2 is half of QP1. So QP2 is half of QP1. Therefore, QP1 is 2 times of QP2. Therefore, this statement QP1 is greater than QP2 by about 100%. This is the correct answer. So the correct answer here is A. So this is the answer. So you can justify it, analyze it by knowing conceptually. So this is 2017 set 2 problems. Friends, I will continue all the problems on pile foundation till date, whatever has been asked in the GATE examination. One by one, we will do it so that while solving the problem, you come to understand the basic concept of pile foundation, which is a very important chapter, and you will be doing all the problems. So you get the knack of solving the problems also. Thank you very much.